Hello everyone, in this video I'm going to talk about the case number 2 of Stadia method of tacheometric serving, in which the staff is being held vertical and line of sight is inclined. Now consider a cross section of a land that is being shown in this figure, and it is being asked to calculate the horizontal distance and also the vertical distance between the 2 points. Let's say that those 2 points are A and B, and from our previous knowledge that we know that in order to determine the distance between the 2 points we need to place the tachometer at one point and the staff at other point. So let's place the tachometer at point A and staff at point B, and let's say that the required horizontal distance is h and the required vertical distance is v. And with the current knowledge, if for example if we have a line of sight that is horizontal, like the same topography that is being considered for case number 1, then here you can see that the line of sight is not striking with the staff. It means in this kind of topography the case number 1 will not be valid. Therefore we need to incline the line of sight so that we can have the staff readings. The angle of inclination is theta with the horizontal axis, and from our previous knowledge we know that there are 3 readings are being taken on the staff, as upper Stadia reading, central Stadia reading and the lower Stadia readings. So let's say that the upper Stadia reading is C, the central one is D and the lower one is E. And we also know that the difference of upper and lower Stadia reading is staff intercept, and here it is being represented as S. Now if you remember the case number 1 where the central line of sight was perpendicular to the staff as shown in the upper right figure, and the formula in that case was f for I multiplied by s plus f plus d, where f for I is multiplying constant and f plus d is additive constant, and that depends upon the type of lens that we are using in the tachometer. The only thing or the only variable in this equation is the staff intercept. But in the case number 2 we can see that the central line of sight is not perpendicular to the staff. Therefore we need to draw an imaginary line so that that imaginary line would be perpendicular with the central line of sight, and that imaginary line would be making the same theta angle with the vertical staff. Now using the same formula we can calculate this inclined distance d, but the condition is that we should be knowing the Stadia readings on that imaginary line. So in order to have the Stadia readings on that imaginary line, let's project the point C to point C dash and point E to point E dash. So the difference between the C dash and E dash will give us the Stadia intercept as S dash. So S dash is actually the Stadia intercept on imaginary line. So the formula of case number 1 can be rewritten as, here the only difference is S dash, which is the Stadia intercept on the imaginary line. But keep in mind that we don't require the d distance, the inclined d distance, but actually we require the horizontal distance h. So in order to determine the horizontal distance h, we need to consider this right angle triangle. In that right angle triangle the base is h and the hypotenuse is d. So in order to determine the horizontal distance we need to have a relationship between h and d. Since h is a base and d is a perpendicular in this right angle triangle, therefore we need to use a trigonometric relationship that have base and hypotenuse, and that is cos theta. So cos theta will then be equal to h over d, and by cross multiplying then we have h is equal to d cos theta. We have the formula for the d, so putting the value of d in the formula of h, the resulting equation would be, so looking at the equation h, we have two variables as theta and s dash. Theta is actually the angle of inclination, and that can be recorded on field, but s dash is a staff intercept on the imaginary line which cannot be determined on field, but the real Stadia intercept, which is s, can be determined on field. Therefore we need to have a relationship between s and s dash. So in order to have the relationship between s and s dash, we need to consider these two right angle triangles. So in these two right angle triangles, CE is real Stadia intercept, C dash E dash is the Stadia intercept on imaginary line. Looking further into it, we can see that s dash is actually the base and s is the hypotenuse. So again we need to use the trigonometric relationship that contains base and hypotenuse, and again that is cos theta. So that cos theta would be equal to c dash e dash over ce. We know that c dash e dash is s dash and CE is S, so replacing them, so ultimately then we have a relationship between S dash and S, that is S dash is equal to S cos theta. Now putting the value of S dash in the previous equation that we have got, after putting the value of S dash, the final equation will then become f or I cos squared theta into S plus f plus d cos theta. Now this would be the final equation for the horizontal distance. Now looking at this equation, we have again two variables, theta and s. Now both these two variables can be recorded on field. So this is the final equation for the horizontal distance between any 2 points when the staff is being held vertical and the line of sight is inclined. Now let's start discussing how we can calculate the vertical distance v. Let's say that the central Stadia reading is equal to h and the remaining distance is p. So in order to determine the distance v, that will be equal to h plus p, where h can easily be determined on field, which is actually the central Stadia reading, but p is actually the one that we cannot determine on field. So therefore we need to formulate a formula so that the p can be determined. For that we have to consider the same right angle triangle, and in that same right angle triangle the hypotenuse is d and the perpendicular is p. So in order to have a relationship between d and p, we need to have again a trigonometric relationship that contains the perpendicular and hypotenuse, and that is sine theta. So sine theta is equal to p over d. By cross multiplying, then we have p is equal to d sine theta. Now again recalling the same formula for the d, which is equal to f or I s dash plus f plus d, and we know that we have a relationship between s dash and s, which is s dash is equal to s cos theta. So putting that value of s dash, we can have the final formula for the d as f or I s cos theta plus f plus d. So now putting the value of d into the equation of p, we can have p is equal to f or I s sine theta cos theta plus f plus d sine theta. Now using a trigonometric relation as sine 2 theta equal to 2 sine theta cos theta, we can simplify this equation as b is equal to f or I sine 2 theta upon 2 multiplied by s plus f plus d sine theta. And now in this equation we have again two variables as theta and s, and both can be determined on field. So once P is being determined, the value for V can easily be determined. Now in some cases it is also being required to calculate the reduced level of point B or A. So for that we should be knowing a point where the reduced level is known, and that is benchmark. So let's say that the benchmark is over here, and to proceed further we need to have the staff reading at the benchmark. Let's place the staff at benchmark, and taking the staff reading at the benchmark as backside. So the formula for the reduced level of point B would be then equal to reduced level of the benchmark plus backside reading. That will give us the reduced level of the axis of instrument, and in order to reach at point B we need to go little down by the value of V. Since we are moving down, so that will have the negative. So then this would be the final formula to determine the reduced level of point B. So this was the case in which the angle was angle of depression. But sometime we have a case like the one that is being shown here, in which the angle is the angle of elevation. So there would be a little difference in the calculation of the vertical distance. However, the calculation for the horizontal distance will remain same. But in order to determine the reduced level for point B, we need to reconsider some parameters like V as the distance between the point B and the line of sight. H is same, which is the central Stadia reading. Now the P will be equal to the summation of V and H. So in this case the final formula for the V would be P minus H. Again the same formula for the P can be used, and H is the central Stadia reading, and that can also be noted on field. So in order to determine the reduced level of point B, in this case consider reduced level of benchmark first, and in order to have the reduced level of the axis of instrument we need to add the backside reading. And since in this case the line of sight is below the point B, it means we need to move higher than the line of sight by the magnitude of V. So therefore we need to add V in this case. So then this would be the final formula for the reduced level of point B. So this is all from this video. In the next coming video I will be solving an example related to the case number 2. Thank you for watching this video. I believe you will be continuing watching my future videos. Thank you.